combination of rules down here. Okay, for this case, it has to start from T1. Okay, for this case, you can either pick T4 or what? T3. Situation is not the same. You pick T4, okay, you pick, if you only have one terminal, you use that terminal. If you have two terminals, you pick the one relative to the direction of the shear flow. Yes. Yeah, but there's no terminal down here. The first area of moment of area cannot cross the centroid. Right? This is like that's why this is like a court case. This is like a rule. Right? Now watch. First moment of area cannot cross the what? Hey, listen to me. It's not that difficult, okay? The first moment of area cannot cross the what? Centroid. So at point A, you have no choice. The terminal has to be what? T1. Agree or disagree? Right? Below, you have two terminals. Which terminal to pick? It depends on the what? Shear flow. Yes, ma'am. Yes. So for this case, you have no choice because at A is at the boundary, right? You use the smallest thickness. That's the only reason. Okay. Don't worry, it's recorded, so you can watch it again and again. Are we clear? Okay. That's why this is like freaking confusing. Okay, that's why I picked this problem. Are we clear? Yes. Yeah. Yeah. Wong. Say it again. Wong again. What's wrong with you, Wong? Why you cannot take what? Why I cannot take T3? Why I cannot take the green area? Because the shear flow is not in the same direction. Relative to B. Yeah. Because if you look at this diagram, B belongs to the where? Yes. I'm telling you now. Hey? So if you look at B, if you zoom in, right, B belongs on the horizontal. Okay? If B belongs on the vertical, they will write B is over here. Wong, you okay, Wong? If not, later on, I speak Cantonese with you. We're okay? Okay. Okay. So now we are happy, hunky-dory. Okay. So I'll write down here. Okay. I'll write down here. Number one, if there is only one, hey, listen. If there's only one terminal, use that terminal. Number two, if there are two terminals, the correct terminal is dependent on the direction of the be clear. Okay, and this one is unique. That's why it's confusing. Okay, now let's look at this question now. Okay, can we look at this question? Now, this question, I know we are at desperate moment now. We just look at the solution manual and I get worried when you just look at the solution manual without understanding, I get worried. Okay. So now this one is very similar, yes or no? Right? It's very similar. But the rules to apply are different. So you have a beam like this. You have another beam going like this. You have another beam going like this. And you have another beam going like this. Yes or no? Then we are asked, you still design your what? Your shear flow. So if the number of terminal, we have T1, T2, T3, and T4. Right? Okay. Where I draw in dark, this is where failure will occur. Okay. This is where the failure will occur. Okay. So we know we have nails going through the vertical and we have nails going on the horizontal. This topic is on longitudinal shear. Right? So what did I tell you about longitudinal shear? Number one, member must distribute the shear flow first. I like down here first. Number two, fastener or joint will then transmit the shear flow. Okay. So now I'm going to calculate the vertical nail. We're going to consider the vertical nail. Okay. So the formula to apply for this case is Q is equal to VQ over I, and this will be equal to F over S. Okay, the vertical nail. What area are you going to take? Yeah. Is it related to your terminal? What did it say? It must distribute the entire area first. So this is the whole area that you take. Member must distribute the, okay, I put another word more serious, entire shear flow first. So he has to distribute on the entire area independent of your terminal. Can you see that? Okay, so when there's a case, given, I'm not going to find I, so given that I is equal to what? I is equal to 197.7. And we are given Y bar is equal to 3.1 inches. Okay, so this is our geometric. Okay, so when there's a case, the V that is given, we don't know what's our V. Okay, so V we don't know, but we have to find our Q first. So the Q is 12 multiplied by 1 multiplied by 3.1 minus by 1 divided by 2. So the outcome is 3.1 minus 1, 3.1 minus 1 over 2 times by 1 times 0.2 inches cube. Okay. So from there, we know that Q is equal to V is equal to what? V is what we want to find. Or are we given V? We are not given V. V we want to find. Q we know is 31.2. I is equal to 197.7. This will be equal to the force of each nail, which is equal to what? 50. And then the spacing is 2. Now we have to put down here because there are how many nails? 2 nails. Not 1. We put 2 down there. It's not because it's box beam or white flange. We put 2 over there because it's what? 2 nails. Are we clear? If you look at the solution manual, I don't know what the F they are doing, but anyway. So V will be equal to 50 times by 197.7 divided by 31.2 is equal to 316.8.827 pounds. Are we clear? Okay, that's why the solution manual, just look at the final answer, follow whatever I teach you. We clear? Okay? Yes, sir. Huh? Just look at the final answer. Use my technique. My technique is like muchas gracias technique. You know, it's really, really good. It is more advanced than how Donald Trump calculate tariffs. Are we clear? Okay. So now we look at the horizontal nail. Now, does this make sense to you? Yes or no? Right? Don't look at the solution manual. It's like Stevie Wonder, you know? You know who Stevie Wonder is, right? So now the Q, now for the horizontal, you take this whole thing, yes or no? Why you take this whole thing? Because you have to, it's all on the what? Horizontal Q now. We clear? Okay, so from here, we have the 6, the width, the depth, and then we have to be careful with the Y bar again. So the Y bar is equal to 1517 minus by what? Minus by 3.1. Okay, then minus by 1 divided by 2. Okay, so 7 minus 3.1 minus 0.5 times by 1 times by 6 is equal to 20.4. Then you use the same formula where we have Q is equal to V multiplied by 20.4 divided by 197.7. This will be equal to 50 multiplied by 2 divided by 2. 2 down here is the spacing. 2 down here is because you again have 2 what? Nails. From here, V is equal to 50, that's a 197.7 divided by 20.4 is equal to 484.558. Okay. You're more comfortable now. Okay, I don't want to be confused. Yes. Say it again. It is a box beam, but I divide by 2 because of the nail. Up here, the top is also a box beam, but if you look over here, it's also a what? White flange. Do I really care? No. I only care about the first moment of area. The member must distribute the entire what? Shear flow. Right. Now, students ask me question, and this question was asked, and I want to address this question.